Welcome to 17th lecture in the course of Industrial Engineering and Operations Research. In the last lecture, we discussed about forecasting and we discussed about various models. Particularly, we told you about moving average method and exponential smoothing method. Now, this is the part 2 of the same lecture. We are telling some other things about forecasting. So, sometimes there is some relation between some cause and maybe demand of the product. So, there are some methods which are called causal or explanatory methods, where we can explain that why the sales in this month is more, why it will be even more in the coming month, like that. So, when enough historical data is present, then based on experience it is possible to relate forecast to several factors that cause the trends and fluctuations. Like in the rainy season, the sale of umbrella will increase, that type of thing can be known. So, if these causal factors are measured and can determine their relationship to the product or service of interest, then forecasts of considerable accuracy can be computed. So, factors that are used in causal models are of several types. We have, say, disposable income, then housing starts, inventories and cost of living indices. Then we can have predictions of dynamic factors and or disturbances such as strikes, actions of competitors and sales promotion campaignings. So, like that there can be many factors. If we can identify these factors, then we can have this type of model. Okay. So, types of causal model are this one. So, we have types of causal model, say like this should be causal model. So, we just do causal model and we go to this one. Okay. Causal model, we have regression analysis, econometric methods. In the regression analysis, forecasting is based on regression methods and it establishes a forecasting function called a regression equation. We can set an equation like y is equal to mx plus c, say y is equal to mx plus c type of thing. X may be some factor and y may be the demand of the product. So, this type of regression equation can be fitted. It can be in the several variables also, like we can have C1 x1 plus C2 x2 plus maybe some constant d, like that. So, regression equation expresses the series to be forecast in terms of the other series that presumably control or cause sales to increase or decrease. So, let us discuss something about regression analysis, although some of you might have come across this topic in some other course also. It is taught in statistics also. So, regression analysis, let us say the dependent variable to be forecasted be y, the independent variable is x. Unlike the exponential smoothing method, the independent variable is not time, it may be some other cause. So, mathematically the relation is y is equal to a plus bx. Basically, you can say a plus bx or same thing we have been writing in coordinate geometry, y is equal to mx plus c. So, basically it is a straight line. X is the observed value of the independent variable, y is the estimated value of the dependent variable, a is the y axis intercept, b is the slope of the line fitted to the sample data, that means regression line, like that. So, the values of a and b are such that sigma x minus y square is minimum. That is why So, this is called this one. So, it is basically not sigma y minus, that means rather we should say sigma observed y observed minus y predicted square is minimum. That means we sum the errors basically. So, y predicted minus y observed, any sequence, because I am squaring observed, and then whole thing. So, you sum all the error. So, that is why this is called least square method. That means this we have to minimize this, minimize. So, least square method. Okay. So, this is so if you do that, you can put all the data and then after that you can minimize it by this one. So, we get following equation: B is equal to sigma x y n x bar. X bar is the average value of that series, y bar is the average value, sigma x square minus n x square, and A is equal to y minus b x. So, by this method we can find out A and B. Let us see that this procedure through an example. A construction company renovates old homes. The company has found that its dollar volume, that means total value of renovation work, is dependent on the area payroll. The company revenues and the amount of money earned by wage earners for the last 6 years are provided in the table. Obtain a mathematical relationship to predict sales. So, company's sales was 2 and that purchasing power is given in this column. So, this is in billions and this is x. So, 2, 3, 2.5, 4, 2, 2.01, 3.5 like that. So, then we have sales y, you can sum them, you can find out sigma y is equal to 15. Then similarly payroll, if it is summed, then it will give sigma x is equal to 19. Then you have sigma x square, this is 4, 9, 16, we have squared. So, sigma x square is also here. Sigma x y, the product of this has been done, and then 2 to the 4 like that, and we get sigma x y is equal to this much. So, this has been summed. Then we can find out mean of summation of x column. So, x bar is equal to sigma x by 6, 19 by 6. So, this becomes 3.17, and y bar is equal to sigma y by 6, 2.5. So, if you calculate, B is equal to sigma x y n x bar y, sigma x square minus n x square. So, it comes out to be 0.26. Okay. And then A is equal to y minus bx. So, average is 2.5, this minus 2.6, 3.7, and this becomes 1.68. Then the regression equation is y is equal to 1.68 plus 0.26x. We can actually check that whether it is giving reasonable values or not. If it is predicted that area payroll will be $6 billion next year, then sales can be estimated with the regression equation. So, sales is equal to 1.68 plus 0.26 into 6 is equal to 3.24, like that it can come. Now, of course, there is some error in the estimate. So, we can find out the standard error in the estimate also. The area, the accuracy of the regression estimate is computed by the standard error of the estimate. This computation is called the standard deviation of the regression. It measures the error from the dependent variable y to the regression line rather than to the mean. So, this is given SYX is equal to sigma y minus YC square divided by n minus 2. Y is equal to y value of each data point, YC is equal to computed or estimated value from the regression equation. So, we have the deviation. This we estimated from regression equation. This is the actually data point. You sum them, divide by n minus 2. N is the number of data point. So, you get SYX, and for calculation simplicity and alternative representation of SYX is, this is SYX is equal to sigma y square minus A times sigma y minus B sigma xy divided by n minus 2. So, example, calculate the standard error of the estimates of the previous example. Sigma y square is to be calculated. So, we calculated sigma y square here, that comes out to be 39.5. Sigma xy also we calculated, comes out to be 53.5, and then we put in the formula sigma y square minus A sigma y minus B sigma xy divided by n minus 2. So, we get 39.5 minus 1.68 into 15 minus 0.26 into 53.5, because sigma xy is 53.5 divided by 6 minus 2. There are 6 data points. So, n minus 2, 6 minus 2 is equal to 0.312, and standard error is $0.312. So, this is the standard error, and that means it is the basically standard deviation of your estimate. And maybe you can say plus minus, you can find out the confidence interval by doing plus minus 3 times standard deviation. That will give almost 99.73% data will fall in that. So, the procedure is same, standard error is known, then you can say within plus minus sigma how much, within plus minus 2 sigma, within plus minus 3 sigma, like that you can calculate. So, coefficients of regression lines. So, regression lines are not cause and effect relationship, they merely describe the relationship among variables. Okay. So, it is, you have to, if you are really, you want to understand cause and effect relationship, then in that case one has to study other qualitative things also. Regression equation shows how one variable relates to the value and changes in another variable. A way to evaluate the relationship between two variables is to compute the coefficient of correlation, that whether there is some relationship or not. This measure expresses the degree or strength of the linear relationship, and it is written by R. The coefficient of correlation can be any number between plus and minus 1, and this particular equation is that coefficient of correlation R n sigma xy minus sigma x into sigma y, and then in the denominator it will be n sigma x square minus sum first all these things sigma x, then total whole square multiplied by in another bracket n sigma y square minus sigma y whole square. So, this type of relationship can be used. In fact, all these are the basic formula, but nowadays it is very easy to calculate these things in Excel, MS Excel or any other things. If you, many online calculators are there, and maybe in some calculators also it can be easily calculated. So, this formula has been written for basic understanding, otherwise this can be obtained in Excel sheet. So, coefficient of correlation for regression line. So, although the coefficient of correlation is the measure most commonly used to describe the relationship between two variables, another measure does exist. It is called the coefficient of determination and is simply the square of the coefficient of correlation R square in case of when there is one input variable and one output. The value of R square will always be positive number in the range 0 to 1. So, we have coefficient of determination. In this simple case, there is a relation between x and y, then coefficient of determination is basically nothing but the R square. In the multiple regression analysis, multiple regression means there may be many factors and response is 1. So, it may be something A plus say bx1 plus cx2 like that plus dx3 like that there may be many variables, x1, x2, x3 are variable, a is a constant term. So, multiple regression is an extension of the simple regression model. It allows building a model with several independent variables instead of just one variable. So, here it is not just one variable, there are many variables here. So, how do we develop that formula for multiple linear regression? Here also the least square method is employed. You may find out that error in one day, there may be n data. So, you have sigma I into this I, and this may be yi minus a plus b x1 corresponding I, right, and that data minus, this has to be this also has to be written minus, okay, that means because this is the observed value and this is the predicted. So, we have to say that it is y minus bxi minus c x2 ith data minus d x3 ith data whole square, and this has to be summed up, and finally you ensure that this error is minimum. So, for that purpose you have to do del I by del A equal to 0, del E by del B equal to 0, del E by del C equal to 0, del E by del D equal to 0. So, by you get 4 equations and 4 unknowns are there, A, B, C, D. So, like that you can do that, but here we are telling you in a slightly different way, but you have to understand that both basically amount to the same thing. This point has to be understood by you. So, in multiple linear regression analysis, if a dependent variable y is the function of n independent variable, namely x1, x2 up to xm, then the multiple linear regression model may be written as y is equal to c0 plus c1 x1 plus c2 x2 plus c3 x3 dot plus cm xm plus e, and e is the error term. So, this is the exact equation. In the case when there are n observations, the following n equations can be written. That means there are n data points. So, you have y1 is equal to this much. Okay, you are writing that first. So, 1 2, this is this one E1, and y2 is equal to also is written c0 plus c1 x2 1. That means second observation corresponding to data x1, this is x2 2, like that, and yn is equal to c0 c1 xn 1. That means nth data point of variable x1, nth data point of variable x2, like that we have written. So, yi indicates that the ith observed value of y, and xij indicates ith observed value of xj. So, if this type of thing is there, then these are basically equations, these are n equations we can write in the form of matrix. So, in the matrix form, this is becomes a column vector y1, y2, yn, okay, n equations, and this becomes c0 c1 coefficient are cm only, and this is 1 x1 this much, this is this one, this is, and plus e1 e2 em, because there are, this is cm and this is basically en, it has to be en, okay, this is en, okay, that when I wrote here that it was m, no, it is not m, it is n. However, the coefficient is this m only, because this is x1m and corresponding coefficient is m. So, therefore, what happens that here we write that n into 1. So, here it becomes n into, this size is basically we can say n into 1, n row 1 column, but this becomes n row but m column, m plus 1 column, because here this is 1 and this is m, m plus 1, and this becomes basically m plus 1 because c0 to cm. So, m plus 1 into 1, and this will be basically size will be n cross 1. Now, you can see it is consistent, because if you multiply n into m plus 1 matrix with m plus 1 into 1 matrix, so resulting thing will be n into 1 only, okay, that this one. So, this is, we can write this in the form of a matrix symbols y is equal to x into c, c is the coefficient vector plus e, and e is the error vector. So, our attempt should be to minimize the error vector e. If all the terms in the vector e are 0, the model is perfect. Usually we minimize e in the least square sense. So, the sum squared error is given by E t into e, least square one, y minus x c t, y minus x c is equal to y t y. You are multiplying, you can expand this becomes y t minus x c t x, because x c transpose is c t x transpose, okay. We have formula A B transpose is equal to B transpose into A transpose, okay, that type of thing is there. So, that is why that it is happening that x c into this much. So, y minus, so y t y minus y t x c, and then c t x t y, c t x t x c. So, by making use of the property that the transpose of a scalar is equal to the scalar itself, we can also say that y t x c, because this is just a scalar and this is equal to c t x t y, because if we take the transpose of this, then it will become by this formula A B transpose, B transpose into A transpose. We need not write multiplication sign in between, we just say that B t A t, then it becomes like this. Hence, E t E is equal to y t y minus 2 c t x t y plus c t x t x into c. Now, minimize the last expression with respect to c, because these are the variable vectors. When I am minimizing, differentiating with respect to c, it essentially amounts to that I am differentiating one by one. So, in the matrix we can do it combined way. I mean to say that I have explained you this thing, it is essentially the same thing there, okay, but we are differentiating with respect to coefficient vector this, so you get this type of equation. So, error will be minimized if x t x c is equal to x t y, because 2 cancels here, or c is equal to x t x inverse into x t y. Note that now you can take the inverse of this also, because it has become matrix. So, the coefficient vector can be found either by solving for c from equation 1 using any equation solver or routine, or from equation 2 by taking the inverse, and the matrix x t x inverse x t together is called a pseudo inverse. Because why it is pseudo inverse? Because suppose I would have written y is equal to c times x, therefore, c would have been x inverse y in a simple way, but provided all of these are square. But you know that this thing was not a square matrix, we had n data point n into 1, but the coefficients were different, this one. So, that is why that maybe you had different variables. So, that is why we cannot take the square just like that, but when we have done that procedure, it has become a square matrix, and that is why that we can take the inverse and we can take a pseudo inverse like that. So, this is what one has to understand. See, in a given example that our y was of size n into 1 and x was of the size, because x vector, so that means x1 xm xm, so it was basically m. So, therefore, this was of that size x, so this may become m minus x will be of size say m into 1, okay. So, this is a vector m, and this will become this thing. So, this is y, this is n into 1, okay. Now, it has to be both side, it has to be consistent, and if we say that this becomes x becomes m into 1, m into 1. So, here you have to say, and if we represent this one, so this is x c, okay, but here okay, this x is containing even 1 to this one. So this size of x was here n into m plus 1. Okay, so this is what that x we have given the indication that because there are one m variable, but there are constant. So x was a square type of matrix here and x was of not this one. So x is equal to basically n into m plus 1. So x was equal to n into m plus 1. So naturally I cannot take its inverse. Actually x inverse is not defined, but when you multiply it by transpose, then the things become different, because now if I say that xt into x, so that means because it will become m plus 1 into n, size will be m plus 1 into n and n into, so basically it will become m plus 1 into m plus 1. Okay, so it can be, you can take the inverse of that. Non-linear regression analysis, the procedure for multiple linear regression can also be applied for non-linear regression when y can be expressed as a polynomial function of the dependent variables. Now it should be noted that the fitted multiple regression model should also be tested for some data which have not participated in the fitting of the model. For knowing the performance of the fitting, coefficient of determination can be calculated by this formula: r square is equal to sigma I is equal to n yi minus y mean square minus I is equal to 1 yi minus y predicted, y height is predicted and whole square divided by sigma yi minus y whole square. So this value will lie between 0 and 1. The closer the value to 1, the better will be the fitting. But this type of now coefficient of determination in Excel, MS Excel or some other software, you can get straightway the calculation. You just have to give the data. Then we can, of course, we can do some fuzzy regression model also. We can have, if there are uncertainty, we can represent it by a fuzzy number. There is a fuzzy variable, this is most likely value, membership grade is 1, lower estimate membership grade is 0.5, higher estimate is membership grade 0.5. So a regression model can be developed for predicting the lower and upper bounds of the dependent variable. With this, y can be represented as a triangular fuzzy number by assigning a membership grade of 0.5 to the lower and upper bound estimate, a membership grade of 1 to the most likely estimate obtained by a standard multiple regression procedure. That is same membership grade, whatever is that, you do that is okay. So this is basically a fuzzy number. Fuzzy number is a generalization of an interval number in which interval varies with the membership grade. So if you want to have lower estimate, we can say okay, this is the lower estimate, we can put a superscript L. And similarly we can have upper estimate. Most likely estimate is calculated in usual way as if there is no fuzziness, and this is the coefficients of predicting the lower estimate and these are the coefficients for predicting the upper estimate. Assume that n observations are available. The coefficient can be obtained by solving the following optimization problem that minimize I is equal to sigma to 1 to n C0 u minus C0 L plus Ci C1 u. That means you are basically taking the difference between these two coefficients or these two estimates. You want to have interval as narrow as possible, but simultaneously satisfying the constraint that whatever is the predicted value is smaller than yi, and whatever is the upper estimate, it is always more than whatever your observed data. So that's why these two conditions have been put. One assures the lower bound of these estimates, one assures the upper bound. So it has become like LP problem, and you can solve that and you can find out the values, and this is what that has been given, and these are the data points. So these are your unknown, C0 etc. are unknown. Now let us discuss about qualitative or judgmental method. Sometimes the past data, even when they exist, may not be representative of future conditions. So estimate of what people think, sampling of how they react to market test, knowledge of consumer behavior and analogies to similar situations may be the best that management can do. So qualitative methods are of considerable significance then because they provide a basis for some important decisions, and these are various methods. One is the Delphi method. We already discussed little bit about that. Market surveys, historical analogies and life cycle analysis, then scenario based forecasting, then sales force composite. In the Delphi method, there are three different type of participants in the Delphi method: decision makers, staff personnel and respondents. Decision makers usually consist of a group of 5 to 10 experts who will be making the actual forecast. The panel of experts can be organized in various ways, and it often includes individuals from both inside and outside the organization. Each panel member is an expert on some aspect of the problem, but no one is an expert in the entire problem. So procedure in Delphi method involves the following thing. First, each expert in the group makes independent predictions in the form of brief statements. The coordinator edits and clarifies these statements. The coordinator provides a series of written questions to the experts that include feedback supplied by the other experts. Steps 1 to 3 are repeated several times. In practice, convergence is usually obtained after a small number of rounds. Market survey is that taking the survey. This method solicits input from customers or potential customers regarding future purchasing plans. It can help not only in preparation of a forecast but also in improving product design and planning for new products. The consumer market survey and sales force composite methods may suffer from overly optimistic forecasts that arise from customer input. This method involves the use of questionnaires, consumer panels and tests for new products and services. Now, historical analogy and life cycle analysis can be also done. Market research studies can sometimes be supplemented by referring to the performance of an ancestor of the product or service under consideration and applying an analysis of the product life cycle curve. For example, the assumption can be made that smart mobile would follow the general sales pattern experienced with keypad mobile. However, it would take twice as long to reach a steady state. Such comparisons provide guidelines during initial planning phases and may be supplemented by other kinds of analysis and studies as actual demand becomes known. Scenario based forecasting. A fundamentally different approach to judgment forecasting is scenario based forecasting. The aim of this approach is to generate forecasts based on reasonable scenarios. The scenarios are generated by considering all possible factors, their relative impacts, the interactions between them and the targets to the forecast. Building forecasts based on scenarios allows a wide range of possible forecasts to be generated and some extremes to be identified. For example, it is usually for best, middle and worst case scenarios to be presented. We can say in the best case this is the, in the middle scenario this is the situation, like that. Thinking about and documenting these contrasting extremes can lead to early contingency plan. Now, sales force composite. In this approach, each salesperson estimates what sales will be in his or her region. These forecasts are then reviewed to ensure that they are realistic. Then they are combined at the district and national levels to reach an overall forecast. For example, evaluation of this approach occurs at Maruti Hyundai, where every quarter these dealers have a make meeting. At this meeting, they talk about what is selling, in what color and with what options. This way the factory knows what to build in the near future. So, like that we can have various type of forecasting method. So, this is all about forecasting I want to tell, and in the next lecture we will come up with a new topic. Okay. Thank you very much.